Good day, learners. In this video, we're going to discuss the lesson Exterior Angle Theorem. Under this lesson, we're also going to discuss two subtopics. The first one is the exterior angle inequality theorem. The second is the corollary of the exterior angle theorem. Let's start first with our main key idea, the exterior angle theorem or EAT. It states that the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. But before we proceed on illustrating or discussing the main theorem, we're going to go back first on the following important terms. The first one is the exterior angle. Exterior angle is an angle formed between any side of a triangle and the line extended from its adjacent. Let's have the following triangles. Let's focus first on the yellow triangle. If the bottom side is extended, therefore we could make or form an exterior angle. Next, let's proceed to the second triangle, which is the blue triangle. If we're going to extend the upper side or upper left side of this triangle, extend its side to exterior part, therefore, we could also form an exterior angle. And last one, the orange triangle that we have, if we're going to extend downwards the right part or the right side of the triangle, we're going to form also an exterior side or exterior angle. So therefore, given these illustrations, we do have angles 1, 2, and 3 as our exterior angles. Now let's use the following illustrations to discuss the second important term, or we call the second important term. The second term is the remote interior angle. What are those remote interior angles? The remote interior angles are those two angles inside a triangle that are not adjacent to a specific exterior angle. Let's have first triangle number one, which is the yellow triangle. Based on the illustration, we have an exterior angle that is angle 1. And as stated, the remote interior angles are two angles inside the triangle, but at the same time, it is not adjacent to the exterior angle. So, therefore, the two remote interior angles are located on this part. So, let's label it as angle 4 and angle 5. Now, let's proceed to the second triangle, which is the blue triangle. Okay, let's proceed to the orange triangle before we proceed on the last triangle. That is the blue triangle. Okay, let's have the orange triangle. Based on the illustration, the exterior angle that we have is angle 3. Now, we can see that the two angles that are located inside and not adjacent to it are these angles. Let's label them as angle 6 and angle 7. So therefore, angle 3 is the exterior angle, and angle 6 and 7 are the remote interior angles. And lastly, the blue triangle with angle 2 as its exterior angle. Obviously, we have the two remaining angles that are located inside and not adjacent to it, and let's label it or them as angle 8 and angle 9. So therefore, we can see that angle 2 is the exterior angle, and angle 8 and 9 are the remote interior angles. So now that we already recall the following important terms, let's proceed to the exterior angle theorem. According to the exterior angle theorem, the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. In this case, we're going to use the first triangle that we have, the yellow triangle. We already know that angle 1 is the exterior angle, and we have two remote interior angles, which are angle 4 and angle 5. According to the EAT, Angle 1, which is the exterior angle, is equal to the sum of angle 4 and 5 that are which are the remote interior angles. Let's have the following measures. If the measure of angle 4 is equal to 35 degrees and angle 5, which is equal to 65 degrees, what is the measure of angle 1? Now, to obtain the measurement, let's proceed on our solution. First, let's put the equation that represents our theorem, and that is angle 1, or the measure of angle 1, is equal to the measure of angle 4 plus measure of angle 5. Then after that, let's proceed to substitution. Angle 4, or the measure of angle 4, is equal to 35 degrees, so we're going to put 35 degrees on it. And the measure of angle 5 is equal to 65 degrees, and we're going to substitute that to the equation. So therefore, we're going to have the measure of angle 1 is equal to the 35 degrees plus 65 degrees. To simplify it further, let's just add the numbers. So therefore, the measure of angle 1 is equal to 100 degrees. And that's it. Now let's proceed to the second example. And this time, we're going to use the orange triangle with exterior angle, angle 3, and two remote interior angles, angle 6 and angle 7. So let's have an equation that represents our theorem. The measure of angle 3 is equal to the sum of the measurements of angle 6 and angle 7. Let's have the example number 2. Look for the measurement of the exterior angle 3 given the measure of its remote interior angles. Measure of angle 6 is 45 degrees and the measure of angle 7 is 65 degrees. Now, for the solution, let's put the equation that represents our theorem. Okay, then substitute just like the previous example. So the measure of angle 6 will be 45 degrees and the measure of angle 7 will be 65 degrees. So therefore, we're going to have this equation. The measure of angle 3 is equal to the sum of 45 degrees and 65 degrees. Simplify it further by getting the sum. We're going to obtain the measurement of angle 3 is equal to 110 degrees. And now, for the last example, let's use the blue triangle that we have on our previous illustrations. In this case, we already know that the exterior angle is angle 2 and we do have two remote interior angles which are angle 8 and angle 9. The equation that represents our theorem is angle 2 is equal to the sum of angle 8 and angle 9. I mean their measures. Let's have example number 3. Solve for the measurement of angle 8, given that we have the measure of angle 2 which is equal to 90 degrees and the measure of angle 9 which is equal to 55 degrees. Let's have the solution. We're going to put first the equation that represents our theorem. Next, let's proceed to substitution. In this case, we already have our exterior angle, where that is the measurement of angle 2, which is equal to 90 degrees. So we're going to substitute there. Then equals the measurement of angle 8, which is the missing measurement. So we're going to put M angle 8 or measure of angle 8. Then plus the measure of angle 9, which is the 55 degrees angle. Now, to obtain or to proceed to our simplification, we're going to apply the additive inverse property of equality, where we're going to add the additive inverse of the term beside our missing angle. And that is 55, so the additive inverse of it is negative 55. We're going to add them on both sides of the equation, and it will go just like this. So on the left side, it will become 90 degrees plus the additive inverse of 55 degrees is negative 55 degrees equals. On the right side of the equation, we're going to have the measurement of angle 8 plus 55 degrees plus its additive inverse negative 55 degrees. Let's simplify it further. 90 degrees plus negative 55 degrees will be equal to 35 degrees. And of course, on the right side of the equation, the measurement of angle 8 will be retained and the sum between 55 degrees and its additive inverse will be equal to 0. To make it short, the answer will be 35 degrees. That is the measurement of angle 8. And that's it. Thank you for listening and see you on the next video.